Hello, welcome back to my channel. I hope everyone are doing good. Okay, so today in this video, we'll try to solve one more interesting problem. The lucky thing is you have correct option already mentioned in the question, but uh, instead of knowing the solution, if you know the answer, there is no use with that. That's why I just want to explain how to do this problem. So the question is, a uniform wire of resistance 18 ohm is bent in the form of a circle. Okay, so the effective resistance across the points A and C we want to find. Okay, so how can we do this type of problems? Let me do it. I am just drawing a circle. Let me take my. Okay, so this is the circular wire. Now I am assuming this as the center of the circular wire. So this angle and this dotted line, what we want to find is the resistance between A and C terminals. So I am just neglecting B for simplicity and considering the total angle here is 90 degrees. Now this is the node C and this is the node A. Okay. Now I want to find the resistance between A and C terminals. In order to find that, what we need to do is we need to consider between these two terminals, means this terminal is same as A and this terminal is same as C. Between these two terminals there are two resistances that are connected in parallel. Okay, as though it is not showing in the diagram, we need to consider them as in parallel. How can we consider that? Let me show you. So from C to A, this is one part of the wire which is connected, and between C to A, this is another part of the wire which is also connected. Okay, so between C and A there are two resistors which are connected in parallel. Okay, in order to find the equivalent resistance, we need to find the equivalent resistance of the parallel combination of two resistors. In order to do that, first we need to consider this angle. Okay, if this angle is 90 degrees, what about this angle? This angle will be 270 degrees because the sum of two angles must be equal to 360 degrees. Therefore, let me consider first resistance R1 uh, for the wire which is making 270 degrees angle with the center. So I'm just writing 270 degrees with the center. How can I find that? It was total resistance actually is 18 ohm. Okay, if you consider the total angle as 360 degrees, the resistance is 18 ohm. But the angle is now 270 degrees. Therefore, 270 by 360 multiplied with 18 ohm. So 93s and 94s and two twos, two nines. So the value of resistance which is having 270 degrees angle with the center is 27 by 2 ohms. Okay. Now I want to find R2. So what is R2? R2 is the resistance which is related to 90 degrees. Okay. Now, so R2, it is related to 90 degrees. How can I find again? It is 90 by 360 into 18. So 91s and 94s, two twos and two nines. So it is 9 by 2 ohm. Now you got R1 and R2. So what we know is between C and A terminals, between C and A terminals, R1 and R2 are connected in parallel because they have two common nodes which are A and C. Okay. Now RAC, let me consider this as RAC. It is equal to R1 into R2 by R1 plus R2. Okay. Now what is R1? Let me just send it towards a little bit upwards. Now what is R1? R1 is 27 by 2. So 27 by 2 plus, sorry, into R2 is 9 by 2 by R1 plus R2. Basically R1 plus R2 is 18 ohm, which is the total resistance. No need to do it separately. Now 27 into 9 in the numerator by, you will get 4 into 18 in the denominator. So 9 ones, 9 twos. So finally what you will get is 27 by 8. Okay. If you perform the division, so let me do the division here. 27, 8 3 is 24. We know that. 7 minus 4 is 3 you have, and you need to take a decimal point and you will have a 0. 8 3 is again 24, right? Very good. 24. 30 minus 24 is 6. You'll get 0. And 8 sevens is 56. 60 minus 56 is 4, and we can add 0. Finally we got 8 5s 40, so the remainder will be 0. Now we can stop our division here. Therefore 27 by 8 we got as 3.375 ohm. So this is the value of resistance between the terminals A and C. Okay, so A is the correct answer. In this way we can solve this simple problem using parallel combination of two resistances. I hope this video gave you some understanding on how to find the equivalent resistance in some special cases like this. Okay, if you really want to support us, please hit a like button and subscribe to our channel. Thank you very much for your cooperation. We will get back into another video.